Good morning, good evening, good afternoon, guten Tag. Uh, the transcription didn't translate to German. Well, welcome, and this is BIO112. Just making sure that see my screen. We are now doing chapter 5 video. Second, okay. So we are in chapter 5 with tissues, and of course it's the study of histology. We already have that down. There are 4 major types. Epithelial, so think skin. Connective tissue, think like ligaments and tendons. Muscle, of course, muscle is muscle. And nervous, of course, is your neuron. And again, I think I went a little bit too deep on my lecture, but we're going to keep it a little bit more simple for this particular video. Now, all the tissues are just simply cells all glued together. So how do they all get glued together? Well, there's 3 ways to do it. Tight junctions, desmosomes, and gap junctions. The tight junctions, they're what? They're tight, right? And they're like every couple of, I don't know, millimeters or microns. Then you have others, which is desmosomes, and you can see these little fingers that connect to each other, and that's another way they can communicate. But the gap junctions, we talked about how there's like a direct tunnel of connection in between. So those are ways that cells kind of get glued together. Okay. Now let's talk about the first type of tissue, which is epithelial. They, of course, they cover their skin on the outside, of course, but they're also on the inside as well, and they also make up glands. Well, inside or on the bottom part, those were all the new cells, and that's your basement membrane. Typical epithelial tissue, if we recall one of the last lectures that we did, they're avascular. The top layers don't have any arteries or veins, and they also don't have too many nerves either. Now, the shapes, that's important. The flat one is, of course, squamous. That's the one where, shingles on your roof. Cuboidal, cube shape, remember the glands, right? And columnar, that's the tall ones. And the big thing about columnar is the villi or microvilli or cilia, and associated with the tall glass-shaped goblet cells that make mucus. Now, the layers could be this simple, just one single layer, or they could be stratified or in multiple layers. And of course, the columnar could also be pseudostratified. It looks like it's layered, but it's not. Now, when we look at this, of course, the epithelial layer, and you can also cover the inside of your lungs, but also the outside and the upper layers of your skin. Those layers are all flat. Okay? Cuboidal, think what? Cube, like boxes. Think gland, think kidney. The columnar, I want you to think like these ones here. I don't think I reiterated it. I just gave it as an open example. But the simple columnar epithelia with goblet cells and microvilli, I want you to think your small intestines. But the ones with the cilia, pseudostratified, think the bronchioles or the little passageways inside your lungs. So this is kind of like a clarification. I think I glossed over this part and kind of put these two together, when in reality they're 2 separate things. But I did mention in lecture that the function of the goblet cells and mucus in the GI is for lubrication, and the function of the goblet cells and the mucus in your bronchial tree or in your respiratory tract is for an immune function to trap foreign body viruses and potentially pathogenic bacteria. Okay. Now, the stratified squamous epithelia, or on the outer layers of your skin, they have keratin in it. And keratin, the function of keratin is to waterproof and to give strength to that outer layer. Remember the theme that we're talking about in anatomy and physiology. Everything on the outside has to be strong, and everything on the inside has to be, a little bit more delicate. So the layers on the outside have to protect the layers on the inside. And you can see here, look at that, bad things have to go through all of that. Here's your basement layer, the dark purple right here, okay? And then these are newer cells. They're living, but then as they go up, they apoptosis, they die, and then they form a nice stack or nice layered or stratified squamous epithelia to protect the outer layers of your skin. And this entire thing here is your epidermis, or the outer layer, upper outer layer of your skin. Now, if you look at the cuboidal cells, right, of course, think glands. And this is a nice little picture here of this patient's looks like submandibular gland. Yep, underneath there. You have three glands, just as a side note. You have submandibular, which is underneath your mandible or your jaw, your sublingual, which is underneath your tongue, and your parotid, which is in your cheek. And those are your three salivary glands. And they store saliva and enzymes that will help break down food. Transitional epithelia, also known as uroepithelia, I want you to think of it as what? Bladder, ureter, things that line your urinary tract, because your urinary tract either is full of urine or it's waiting to have urine, so it has to be able to expand. Okay? And right here is a classic example. Like you see the teardrops, and the teardrops can expand. So just think, when we're thinking, if you see transitional, I want you to automatically think urinary bladder and your ureters. These tubes right here that go from your, let's see if I can make them a little bit bigger. These are your ureters right here, and this is your urinary bladder. Those are all transitional epithelia. And you can see, the way I kind of remember it, like an umbrella. You see how it's like that, and then it could expand and open up just like an umbrella. Glandular epithelia, remember, cuboidal. You either have endocrine, of course. The classic example is your pancreas releasing glucagon and insulin into your blood. Exocrine, think, sweat glands. Exocrine glands can either be unicellular, that's easy, that's only one, such as a goblet cell, and multicellular, you have a lot of sweat and you have a lot of salivary, more than one salivary gland, so that's multicellular. Merocrine, apocrine, and holocrine, it's better to look at this as this big picture. Of course, merocrine glands only release a little bit. Classic is your salivary gland, submandibular, pictured here. Your apocrine gland has, in the medium, a little bit more release of glandular products. And the classic example is your mammary glands or breast tissue. And of course, holocrine gland. That the example is sebaceous gland. It's going to release the entire cell. And then the cells have to redivide, and you can see here there's mitosis going on. And how do I know it's mitosis? Mitosis is a somatic cell. It's going to make the same copy over and over and over again. That past picture, beautiful picture, wonderful for not only the lab questions, it's also good for a lecture question. So that beautiful picture, I can easily erase all of this and just do what? Just keep the A, B, C. And then could I just shuffle them around? Yep. Now, connective tissue, think things that bind together, right? Also storage of fat, also blood cells, right? So let's look at some classic examples of major cell types of connective tissue. Fibroblast, think blast is a immature cell of fibers, and it's going to make more fibers to give our body structure strength. Macrophages, also known as a histiocyte. Macro means big, phage means eat. Those are the ones that have phagocytosis. So if I put that on an exam, think immune function. Remember, they're thugs. They don't think too much. All they do is what? Defend against infection. And they only go where they're told. And we're going to talk about more about that when we talk about the immune system. Mast cells. I want you to think two things. Release heparin, release histamine. So mast cells, the two H's. Think heparin prevents clotting or thins out your blood. Histamine, again, induces the inflammatory response. Three types of fibers: collagen, elastic, also known as yellow, and reticular. Collagen, think what? Super strong. Elastic, strong but flexible, right? And reticular, think thin, delicate, and think liver and spleen. Reticular, I want you to think some sort of like filter, like the liver and the spleen is. Nice picture. Connective tissue, think cartilage, blood, and bone. That's another more of connective tissue. Bone and cartilage are the same exact thing, but bone has more calcium. Cartilage doesn't have much calcium, or if any at all. Other things you're going to think of, areolar connective tissue, fibroblasts, nice to know. Adipose tissue, must know. Stores fat, and you can see, big, it's cushiony, right? But you see, what do you call it? Ground? They call it ground substance, or when you look at reticular fibers and such as, like you look, it forms this matrix here. This, remember, form equals function. This is a big space, and it even looks like a cushion, like you know those what do you call those packaging peanuts that you put in if in a box if you don't want things destroyed. Reticular connective tissue, we just talked about that. Dense regular connective tissue, that's very strong. Tendons, ligaments, and of course the dermis, which is the main section of your skin. Now, remember, a tendon is a connective tissue that connects muscle to bone, and ligaments typically connect bone to bone. Nice to know. Remember, lecture is more about the words. Lab is more about the pictures. And we're going to talk more on Friday, or on Fridays, about what kind of pictures look good. Dense, elastic, yeah, we already talked about that. Cartilage, also known as chondrocytes. Chondro means cartilage. Three types of cartilage. Most common, hyaline, right? Then you have elastic. Think your voice box, your larynx, and your vocal cords, because they have to be elastic. And last but not least, fibrocartilage. I want you to think the classic example is your intervertebral disc of your the bones in your spinal column. Where's that picture? Here it is. So just these orange things, that's cartilage, and that's in between these vertebra, these bones in white. That's why they're called IV discs or intervertebral discs. Bone, of course, lots of calcium salts, lots of collagen, because it has to be very, very strong. On the outside, it's compact, but on the inside, it's kind of spongy and open. And it's spongy and open because the spongy bone has marrow in it. You have yellow marrow and red marrow. We're going to talk more about that in future lectures regarding bone. But the yellow marrow has fat in it, and the red marrow has blood in it. Compact bone forms these units. And remember my analogy I talked about, like all your compact bone is made up of essentially these units called osteons. So start thinking of them as like twigs with like a canal for arteries, veins, and nerves inside them. And you bundle up a whole bunch of twigs together, and then you wrap them all together nice and tight. You get what? You get a very, very strong stick. and that's essentially what bones are. Blood, know the difference between red blood cell, white blood cell, and platelet. Red blood cell, also known as erythrocyte. White blood cell, also known as leukocyte. Platelets, also known as thrombocytes. Red blood cells transport gases. What are the two gases? Oxygen and carbon dioxide. Red blood cells also transport nutrients. We'll talk more about that later. White blood cells, there's different types. We'll talk more about that later, but they defend against infection. And platelets, also known as thrombocytes, through the blood clotting cascade, and also with the help of other substances like fibrinogen to make fibers. Platelets are very sticky, and they prevent blood from leaking out of all of your tubes, and that's why we have blood clotting. Beautiful picture for your laboratory. Of course, this is the biconcave disc of your red blood cell. It looks like a lifesaver. There's nothing in the middle, hence it's anucleated. But what's really in the middle is no nucleus, but it has hemoglobin, which is the blood protein, blood, globin, protein, that carries oxygen, carbon dioxide, among other things. Here is a platelet, which is essentially just a sticky cell fragment. And of course, this is a white blood cell, this is a white blood cell. White blood cells have nucleus, like this big one here, and this one here. We're going to talk about the differences between the white blood cell, which is also known as your white blood cell or your leukocyte differential. Serous membranes, we already know, right? Visceral versus parietal. Mucous membranes, we already talked about goblet cells. You should know about that. Cutaneous membranes, think membrane covering, think skin. Synovial membrane, think covering or pockets where the joint cavities have these little pockets. They're called bursa. Learn more about that when we talk about the joints. And synovial membranes are membranes or coverings that cover joints that are fully movable. Okay? General characteristics of muscles. Now we're on to muscles. And it's better to have that chart. You can look up that chart. But on that chart, you have striated muscle, which is skeletal muscle, which is voluntary. You also had smooth muscle, that's visceral. The muscles in your lining your hollow organs in your gut or your viscera. And then last but not least, you have your cardiac muscle, also involuntary. You have the intercalated discs here, and those are the ones that store calcium, because my heart forms a syncytium, meaning to say is it can beat on its own. It can contract on its own, and I don't have any control over it. Nervous tissue, of course, the neuron or the nerve cell is the star of the show. Its only function is for communication, meaning the electricity and or the chemical signal that goes up and down. And we already know up, sensory, down is motor. Up is also, your ascending fiber is also known as your afferent, A-F-F-E-R-E-N-T, and your descending fibers, also known as your motor fibers, are your efferent pathways, E-F-F-E-R-E-N-T. So neurons are the star, but the neuroglia or neuroglia, potato, those are the support cells. So the neuroglia are the ones that feed the neurons. It's the one that changes the diapers. Well, to an extent, it can't really repair the neurons, because remember what we talked about in class? Once you destroy a neuron and once you get rid of it, it's gone forever. And we only have a finite or a set number of them. So every time you trash your neurons, whether it be traumatic brain injury, a loss of oxygen, or a little bit of alcohol abuse, then you lose that neuron forever. And that is the quick summary of Chapter 5. Thanks for playing, and I'll see you guys in class. Have a good one.